Now, just a short recap on the previous video. Now, when a point or a coordinate is reflected in the x-axis, so let's compare the coordinates with each other. So B was 1 and 4, and reflected through the x-axis. If you really look at B prime, you would see that the only thing that happened to the values when you're reflecting a point through the x-axis, the x value, it doesn't change, only the y value. So if we have, for example, P, which represents, let's say, 7 and minus 8, if we should reflect this point through the x-axis, what value would change? Not the x value, but the y value. So it would be P prime would represent 7 and 8. So if we have a negative, if we have a positive value in the y place, it will change to negative. If it's negative, it will change to positive. So let's do a small representation here. So for example, P prime is on this side. So you know that 7 is positive, which is the x value on this side. This is the x-axis, this is the y-axis, and the 8 would be negative down here on the y side. So if we should reflect this point through the x-axis, it would fall somewhere about here. So just a small recap on that. So we're going to look at how we would determine the 2x2 matrix. That represents the y-axis reflection. So if you realize with the x-axis reflection, what value changed? The x value doesn't change, only the y value. So as if you can predict these type of things, what value do you think would change when we're doing the y-axis reflection? Not the y, but the x. So let's see. First thing, I'm going to set up a small Cartesian plane. X-axis, y-axis. This point right here, let's say this point is 1, 0. This point right here is 0, 1. This point right here is negative 1 and 0. And this point down here would be 0 and negative 1. So, with this particular question, remember, we're doing a reflection in the y-axis. So the y-axis is now the mirror line. So I'm going to make it a bit brighter. So this would be the mirror line, or the axis of reflection. Now, we always start from the x value, as in this would be 3 o'clock and a clock. Up here would be 12 o'clock. So whenever we're doing a reflection or a rotation, we always start from 3, finish with 3 o'clock, we move on to 12. And that's just how it is. So we're going to reflect this point right here. We're going to reflect it across the y-axis. So remember, the same distance from the object point to the mirror line is the same distance from the mirror line to the image point. So we'll just go 1 to the mirror line, then 1 from the mirror line. So we always write the coordinates where we stop, not where we start. So we would have right here, we would have negative 1, 0. That's the first set of values. Now, if we're reflecting on the y-axis, we move on from 3 to 12. This would be the invariant, and the invariant point right here. So this value can't change because it's stuck on the mirror line. So the value would be 0 and 1. So this would represent the matrix. Now, like we did before, let's test it on our triangle. So this triangle was reflected through the x-axis, then reflected on the y-axis. So let's see. We're going to test C to see if we get C prime, to see if we get C double prime, which is here. And we're going to test B to see if we get B double prime, which was here, which was M. So C prime was what? 3 on the x, negative 1 on the y. And other one, B prime was that was 1 and negative 4. So for C prime, C double prime, the value would be, the coordinates of C double prime would be, that's what, -3 and -1, and the coordinates for B double prime would be -1, -4. Don't know how to do the rules there. Bye. Okay, so let's test this y-axis. Let's test this y-axis reflection matrix. So when we multiply the matrix times C, we should get C double prime. So the matrix, the 2 by 2 matrix that represents the y-axis reflection, we're going to multiply it by C prime to see if we get the image point of C double prime. So first row, first column, -1 times 3 is -3, plus 0 times -1 is 0. Then second row, first column, 0 times 3 is 0. Then 1 times -1 is -1. So we'll add these. So -3 plus 0 is -3. 0 plus -1 is -1. So as you can see, it matches up. So let's try for B prime also. So the 2 by 2 matrix, which represents the x-axis reflection, times B prime, should give us a result of B double prime. So we're going to work this out now. First row, first column, -1 times 1 is -1, plus 0 times -4 is 0. Then 0 times 1 is 0, plus 1 times -4 is -4. So our result would be -1, -4. So as you can see, the values, they indeed matched up. So it's either you're going to swap these matrix or understand how to determine them, but by any means you need to know about the 2 by 2 matrix for the exam.